All right, guys, welcome back to lesson number 18, where we're talking about particle motion, total change, fundamental calculus, all those fun things. But really, this is videos on total change theorem. And problem number 8 says a particle moves along the x-axis so that time t is greater than 0, its acceleration is given by this cosine function you see here. If the velocity of the particle is -2 at time equals 0, then the speed of the particle at time equals 2 is equal to what? So we're going to do a little thing right now. So we're back to our first page, and we haven't talked about this yet, so we will. That speed is going to be the absolute value of your velocity at time equals t. If you guys look at these problems right here, you can see that the absolute value of your velocity at time equals t is going to be equal to your speed. So all we're going to do in our problem, all we have to do now in our problem here is find our velocity at 2 and then take the absolute value of it. Well, we know how to find the velocity at time equals 2 if we're given the acceleration function. So we're going to find v of 0, and then we're going to add the integration from 0 to 2 of the acceleration, the integration of the acceleration. And again, we're going to take the absolute value of this function. So we know that this v of 0 is going to be equal to -2. And then again, this is a calculator problem, so you would integrate in your calculator from 0 to 2 your cosine function, 1 minus 2t dt. And usually if you guys can't integrate something, it's going to always be a calculator. If you can't do it by hand, then it's going to be a calculator problem. So once you do this in your calculator, you're going to get, again, this is -2, and this is going to be plus 0.613. And again, we want the absolute value of that. So this is going to give us a -1.387. And if I want the speed of this, then I want the positive of this value. So this answer is going to be D. Okay? So if you're trying to find the speed of a particle at some time, go ahead and do whatever you normally do. You're using total change. Take the initial, do the total change on that interval, and then just change its sign. Well, actually make it positive. It's going to be the positive value of that, because this is our velocity at time equals 2. All right, so let's move on to another question. There's the next couple I just want to talk about. I don't necessarily need to do, but I like question number 10. It says the acceleration of the body moving in a straight line is given by this acceleration function. If the velocity of the body is 25 at time equals 1, and if s of s is the distance of the body from the origin of time, what is s of 4 minus s of 1? Or s of 4 minus s of 2. So I want you guys to know, what are you really finding here? So you guys remember, based on the fact that we now know total change, is that if I were to find the integration of 2 to 4 of our velocity, that's going to give us our position function. So this is what we have to find. This is all we have to do, is find this integration of 4 to 2. So we don't have to worry about doing initial conditions on our position function. So how do we find our velocity? Well, we're going to integrate that, right? We're going to integrate this 8 minus 6t dt, and remember, this is going to give us our velocity function, right? The integration of acceleration is going to give us our velocity. So we set this, and we're going to get 8t minus 3t squared, and then we're going to do a plus c. And then you're going to use the fact that when time equals 1, we're going to have 25. So then we're going to have that c is going to be equal to 20. So our velocity is going to be equal to 8t minus 3t squared, because again, we integrated our acceleration, plus 20, because we found that using the initial condition. And so we solve this problem by integrating this function, 8t minus 3t squared plus 20, on the interval from 2 to 4. This value is going to give us what s of 4 minus s of 2 is. These could have been any numbers. If this had been a 5 and a 1, then we would integrate it from 1 to 5. So this question is just letting students know that the displacement is just the integration of your velocity. All right, and if you do this problem, you will get the answer of 32. And this would be one that you would do by hand, because again, this is not a calculator question, and you could absolutely integrate that by hand. It takes a while, but you could do it by hand. So just a good little bit of conversation I want to have there with this. So this, again, is equal to your integration of your velocity. So let's move over and look at question number 11. So we're going to do this one. This is, again, displacement versus distance. And now we have a visual representation rather than a algebraic function. So it's basically saying to us that we have a particle moving along the y-axis with our velocity of v of t from 0 to 5. The graph of v of t is shown to the right with the positive areas of p, q, and r, and then our technical negative area of q right here. This is technically, they're all positive, but this is going to be a negative value for us. We'll get to that in a minute. What is the difference between the distance and its displacement? So notice that the question is giving us our distance first. So we want to know what our distance is first, and we're going to subtract our displacement. So distance, again, is going to be the absolute value of our velocity. So we want all positive stuff. So we're going to go p. That means that we went p units to the right, and then we went q units to the left, but we still traveled them. Then we went q units to the right, and then we went q units to the left. So we still travel all of these distances. So our distance is going to be p plus 2q plus r. Okay, so that's going to be our distance that we traveled. Displacement, based on this picture, is just going to be our velocity. And so this is going to be p minus q, right? So we're walking forward, and then we're starting to walk backwards. So our distance, remember, our displacement is our distance from where we started to where we ended. So we do have to take that into account. That's negative, plus q, and then again, minus r. So this is going to be negative and negative for our displacement. This one we do care about our signs. So the q's are going to cancel, and we're going to be left with p minus r. And so the question's asking us what's the difference between, and again, the distance was first, so we're going to go ahead and do distance minus displacement, and we're going to get p plus 2q plus r minus p minus r. So just be careful, we're subtracting the whole thing right here. We want to make sure that we do not make a silly mistake here. So p plus 2q plus r minus p plus r. So I just distribute the negative, and so you guys can see that the p's cancel. And so I'm left with 2q plus 2r, and so our answer is going to be E, right? We're going to factor out that too. So that's how you do question number 11. Okay, so we've seen distance and displacement based on our functions, and now we've seen them as a group. So problem number 13 is the last one I want to do in this video, and again, it's just a good talking point for us. I don't want to do the whole problem, but just the idea of what we need to do here. So it's given us the acceleration, and we know that because this is our notation for a second derivative. So the acceleration of our particle is given by the function 2 plus t squared, or sorry, 6t. Again, our units also tell us this is a second derivative or acceleration, meters per second squared. At time equals 0, the velocity is 6 meters per second. It says find the velocity as a function of time. So you guys know what I just talked about before is that if I integrate, and again, I'm not bounded by anything here, so I want at any time t. So for this one, these are indefinite integrals, so I'm going to integrate this function 2 plus 6t. I'm going to get 2t plus 3t squared plus c. And just like before, if I say to you guys at time equals t, so velocity of 0 is equal to 4, that's going to give me what our c value is. So 4 is going to be equal to 0 plus c, so c is obviously going to be equal to 4. So our velocity at any time t is going to be equal to t squared plus 3t squared, 2t, my lord, 2t plus 3t squared plus 4. So that's the answer to part A. Pretty straightforward with that problem. Question B says, how far does the particle move during the first second of its trip? So how far? That is asking for distance, right? That's asking for distance. So we're going to integrate from 0 to 1 our velocity function, but the absolute value of it. And if you've written, by the way, the velocity is equal to this is complete proper notation. You don't have to write out 2t plus 3t squared plus 4 every time you do this. You do not need to do it. And then you would then integrate that function, right? You would integrate that function. A point here is that, and you guys could, graph this to see it, but it's actually positive the whole time, but I'm going to keep the absolute value on it just because I want to. But yeah, you would integrate this, and it's going to always be positive, but this would most likely be a calculator question and to get your answer. So that would be equal to 6 meters. That's equal to 6 meters. All right, so I think that's a good way to end this video. I hope this all makes sense to you guys, and I'll see you guys in the next video.